Assalamu alaikum dear students. Today we have to continue with the same unit, basic statistics, and the topic for today is measures of central tendency. Let's have the introduction of the topic here.
Meet Zen. He has given 8 algebra tests this year, and these are his scores. In the first test, he scored a 78. In the second one, he scored an 80, and 82 in the third, and so on. So one day, Zara asks him about his performance in algebra. Now Zen has two options. He can either tell Zara about his score in each test, something like, in the first test I scored a 78, in the second test I scored an 80, in the third I scored 82. And the other option Zen has is to tell his average score over the period. So he tells Zara that he scored around 80-81 in the previous year. Here, Zen just approximately averaged his score over the period to give Zara an idea about his performance. This is far more convenient as compared to mentioning the score in each of his tests. Now let's see how we actually find the average. Consider these 5 numbers: 1, 3, 8, 12 and 16. There is a very simple way in which the average can be calculated. It can be calculated as sum of values divided by the number of values. That's how simple it is to find the average. Look at the numerator first, the sum of the values. Sum of these values would equal 1 plus 3 plus 8 plus 12 plus 16. And how many values do we have here? 1, 2, 3, 4 and 5. 5 values. We divide the numerator by 5. 1 plus 3 is 4. 4 plus 8 is 12. 12 plus 12 is 24. And 24 plus 16 is 40. So the average would equal 40 by 5, which equals 8. This is the average of the 5 numbers in the list. The average is also called the mean, or to be more precise, the arithmetic mean.
Dear students, in the previous lesson we learned about frequency distribution and graphical representation of data. But those methods are not enough for representation of data. Therefore, today we are going to learn another method of representation of data, which is the representation of data by a single value known as average, central value, or central tendency. So let's understand what measure of central tendency is. The purpose of frequency distribution and graphical techniques is to view, summarize, and understand different aspects of data in a simple manner. But we are also interested to find a representative of the data under study. As we have the representative of a country or a class, similarly we have a representative of data. So let's understand what representative of the data is. Representative of the data is basically the specific value of the variable under study around which majority of the observations tend to concentrate. The measures or techniques that are used to determine this central value are called measures of central tendency. We can better understand this measure of central tendency with the help of example here. This table shows the marks of the student obtained in a different test at different tests. In the first test, he has scored 78. In the second test, he has scored 80, and so on. Now, if another student wants to know about his marks in 8 different tests, so the first student has 2 ways to state his marks in test. One way is that he can state his marks obtained in each test, which will be very time taking and sounds weird, whereas another way is that he can tell the average marks, as he can tell that his average marks may be between 80 till 81. Why? Because his means majority of the marks in 8 tests are near about 80 to 81. So his average marks may be between 80 till 81. So if he will tell his average marks, it will be more convenient, as he is representing his marks by a single value, which is more convenient rather than telling his marks in each different test. So here we can say that this is the representative of his marks, known as central value or single value or average, around which the majority of the data tends to concentrate. As we can see that the majority of the observations are near about 80 or 81, which is the average of his marks, like 78, 80, 82, 79, 82, 79. So we can say here that central tendency is a single value or a specific value around which the majority of the data tends to concentrate. Here we can have another example. This 8 shows the average of these data or these observation. So this is the central value or a single value or the specific value around which the majority of the data tends to concentrate, is 3, 12, 16 and 1. These all are near about 8. If the average will be here 100, so that is not a correct average for this data, as 100 is far away from this all observation. Similarly, if the average here is 0, so of course that is not the correct average, because 0 is far away from these all observations in the given in the data. Here we have the following the measures of central tendency, which are going to be discussed in this section. The first one is arithmetic mean, then median, mode, geometric mean, harmonic mean, and quartiles. Let me tell you here that all these measures are used under different situations depending upon the nature of the data. Let's begin with the first one, known as arithmetic mean. Arithmetic mean or simple mean is a measure that determines a value of the variable under study by dividing the sum of all values of the variable by their number of observations. In simple words, we can say that mean is obtained by dividing the sum of all the values or all the observations divided by the number of observations. So here we can say that if we have n number of observations, so this x bar is used is the symbol used for denoting arithmetic mean. This is sigma, known as summation x, means sum of x. X is all the observations, so sum of x divided by n. N is the number of observation. So we can write this formula in words as sum of all the observations divided by the number of observations. This is the way of calculating arithmetic mean, or the formula for calculating arithmetic mean. Here we have the computation of arithmetic mean. There are two types of data, ungrouped and grouped data. We therefore have different methods to determine mean for the two types of data. Let's understand how we can calculate arithmetic mean for ungrouped data. For ungrouped data, we use three approaches to find mean. These are as follows. The first one here is direct method. The formula under this method is given by x bar is equal to summation x divided by n. In direct method, we directly add the values and we divide it by the number of observation. This is very simple. As we have the example here, arithmetic mean formula, we are going to add all the observations and we are going to divide this by the number of observation. Here we have the example that get the sum. We are going to add all the observations, then we are going to count the numbers of the observation, 1, 2, 3, 4, 5 and 6. So sum of the observations is 420, whereas the number of observations are 6. So then we have to divide, and this 70 is the average. This is the representative of this whole data. So we can say that representative or central tendency is the specific value around which the majority of the data tends to concentrate. Now majority of the data will be near about 70. It will not be very far away from 70. So the 70 is the representative or the average or the mean of these data. Here we have the other two ways known as indirect or shortcut methods. There are two approaches under indirect method. These are used to find mean when data set consists of large values or large number of values. I am repeating my words again. Large values or large number of values. The purpose is to simplify the computation of mean. These approaches exist in theory but are not used in practice, as many statistical softwares are available now to handle large data. However, being a student, you must have the knowledge of these two approaches. These are using an assumed or provincial mean, using a provincial mean, and changing scale of the variable. We have two methods of calculating arithmetic mean. One is direct method, where you directly add all the values, then you divide it by the number of observation. Whereas the other method is indirect or shortcut methods. This method is useful when we have large number of data or when the values are very large, like values are in thousands or we can say in millions, the data or the observations. So it is very difficult to calculate them in the absence of calculator or in the absence of the statistical softwares. So therefore this shortcut method was introduced. But since now we have now statistical softwares which have made the calculations easy, so therefore this method is not in this does not anymore exist in practice or in practical. It's just in theory, but we must have the knowledge of these two indirect methods as well. The first one is here using an assumed or provincial mean. We're going to understand this today. Using a provincial mean and changing scale of the variable, this we are going to understand in the upcoming lesson. So let's understand that what this using an assumed or provincial mean is, what this indirect or we can say shortcut method is. Okay, this x bar shows the arithmetic mean, and here the formula is changed for the indirect method. Let's understand this here. Here we have a. First of all, we must know that what a is. A is any constant. It is any assumed value of x called assumed or provincial mean. We are going to assume any value from the given data, which is known as a or assumed or provincial mean, which is going to be discussed ahead as well. Then we have here d. D stands for deviation. Deviation is defined as difference of any value of the variable from any constant a. I'm again repeating it. Deviation is defined as difference of any value of the variable from any constant a. Any value of the variable means the values or the observations which are in the data. So the difference of it from what? From the any constant a is known as deviation. Here deviation from any constant a. So xi shows that the observations in the data. For I can be 1, 2 means the first data, then second data, and so on, number of observations that we have. We're going to subtract each of those from a, assumed or provincial mean. Here we have an example. First method here is used direct method. You can see that in direct method we have sum all the observation, then it is divided by the number of observation, and we have the answer 23.5. Whereas the second method is shortcut method, and here we have let me rectify it, there is no x. Here we have the formula x a plus summation d divided by n. Here we can use capital D for deviation. Here this calculation is given directly here. we will be discussing it ahead, and you can see here that either you use direct method or shortcut method, which is known as indirect method, you will get the same answer. The only purpose of using the second method is just to make the calculation simple, or as it's already discussed here, that it is used for just to simplify the computation of mean in the absence of calculator or software, statistical softwares, but we will get the same answers. Okay, here we have some more explanation of this shortcut method, that deviation is equal to x minus a. Here is the formula. It should be noted that any value can be taken as assumed mean. It's known as arbitrary point as well, and the answer would be the same as obtained by the direct method. Here we have exercise 6.2, where we are supposed to calculate arithmetic mean by direct method for the following set of data. We have two parts in this question. The first part is done here, and the second part we have to do in homework, as it is similar to the first part. So we are going to find the arithmetic mean by direct method. As we know that in direct method we are just going to directly add the values, then we are going to divide it by the number of observations. So here's the formula. This is the arithmetic mean, and here's the symbol used for arithmetic mean, and it is equal to summation x, means sum of all the observations in the data divided by the number of observations. So let's say that these all are represented by x. So sum of this all x, 12 plus 14 plus 17 plus 20 plus 24 plus 29 plus 35 plus 45. And how many observations are here? 1, 2, 3, 4, 5, 6, 7, 8. So the number of observations here are 8. When we will add this by the help of calculator, so we will get the result as 196 divided by 2 by 8. When it is divided by 8, so we will get the mean 24.5. So this is the arithmetic mean. This is the a single value, or we can say a central value or a central tendency around which the majority of the data tends to concentrate. As if we just see here, 24.5 is near of 17, near of 20, 24, 29, 35. It's not very far away from these data. So therefore, central tendency is defined as a single value or a specific value around which the majority of the data tends to concentrate. Here we have question number 4. For each of the data in question number 3, compute arithmetic mean using indirect method. Question number 4 states that the data which is given in question number 3, now we have to compute arithmetic mean, but by using indirect method. So here we have to do again the first part, and second part is left for you for homework, because the second part is similar to the first part. And now we are going to use the indirect method. As I told you that indirect method, we are going to have the formula different, which is x bar means the same symbol, a plus summation d divided by divided by n. As I told you that a is any constant or any assumed value, assumed mean, which is taken from the data, as it is discussed here. Let me revise it again. This is here, that a is any assumed value of x. X are all the observations, called assumed or provincial mean, whereas deviation is defined as difference of any value of the variable from any constant a. So let's proceed towards the question here. Okay, here now we have to first of all find a, means the assumed mean. So we can take any constant from the observation, but it is recommended that if we will take any value from the middle, it will make the calculation easy, rather than taking any value from the first observation or from the last. So let's see that if we leave 3 values from here and 3 values from here, so in the middle we will be having 24. It's, I think twice it is repeated, 24, 12, 14, 7, this is 20. Here I am going to take, let me rectify this. Okay, this is 20, not 24. Here it is 24, and now okay, here we have to take any assumed mean, and we are going to see that three values if we leave from here, and if we leave three values from here. Here are the observations written: x 12, 14, 17, 20, then 24, then 29, 13, and 35 and 45. And the number of observations are 1, 2, 3, 4, 5, 6, 7, 8. So n shows the number of observations, which are 8. So if we leave three values from the means we can say top, and three values from the bottom, so in the middle we will be having two values, which are 20 and 24. So it's better to select the assumed mean, known as provincial mean, which we have assumed by ourselves that it is the middle value. So any of them can you take, but if you will take any value from the x or from the data, so it will not affect the answer. So we have selected here the assumed mean or provincial mean as 24, or we have named it as a, the constant, or the assumed mean or provincial mean as 24. X are the observations listed down here. Now as we can see here that in the according to the formula we have to find the deviation. So deviation is equal to x minus a. It means that the difference of the observation or the values from the assumed mean. So let's write x, the first value, and we have to subtract from it the assumed mean, which is 24. By subtraction we will get minus 12, because 24 is the greater number. Now we have to proceed it. Now we have to go with the second value in the data, which is 14. Minus 24 will get minus 10. Now 17. Each of these observations should be subtracted, or from each observation a should be subtracted. So from 17 we have to subtract the provincial mean, we'll get minus 7. From 20 we have to subtract, we'll get minus 4. From 24 minus 24 will get 0. From 29 we have to subtract a, which will be equal to 5. From 35 we have to subtract, and we will get 11. From 45 we have to subtract the assumed mean, and we will get 21. Now what you can observe, that if you will deal this value directly here, is you can see that if you sum this directly, so it will be like if in case of this, if there would be suppose large values, like the values would be in thousands or in millions. So in the absence of calculator or statistical software, it's very difficult to calculate that. However, here just the values are small, and if you can calculate it without calculator. But I'm talking that if the values are very large, so it's very difficult for the statistical field to calculate that or to find the mean in the absence of calculator or statistical software. So therefore, for the ease or for the convenience, they use the shortcut method known as indirect method, where they subtract the assumed mean, where they will take a value, a constant from it, from the given data, then they will subtract that constant from each of the observation in order to reduce that value. Fine. So there will be no any effect on the data, on the answer. The reason I am going to tell you now. So you can see here that this data has been converted now into small values. As you can see here, minus 10, minus 12, minus 10, minus 17, minus 4, and these values have been converted into small values by finding the deviations, or by taking the deviations from 24 from the assumed mean. Now let's put it in the formula here. Now this a shows that, as we know that when we add something, so we have to go with the subtraction. Here what we have done, we have subtracted from each observation 24 in order to reduce the values for the sake of calculation. So at the end again we have to add this value back, because they have been subtracted from the observation. So it is added here, 24 is added here, then plus Now we are going to find the summation of d, means the sum of deviations. It will be equal to 4 by the calculation. Now we can see that here the sum is 4. But if we just go with the direct method, the sum is 96, which is a big number. But by taking the deviation, we have converted the sum into a small value for the sake of calculation. And the number of observation here is 8. So 24 is written as it is. 4 1 is 4, 4 2s are 8. And 24 when divided means when we will solve it ahead, so we can write it 24 1 upon 2 means half, so the answer can be 24.5. This is the way of calculating arithmetic mean by indirect method or by shortcut method. Here we are done with question number 3 and 4 of exercise 6.2. So I hope that you have got the concept. So therefore you have to do exercise 6.2, question number 3 and 4 in your neat notebook. This is all for today. Stay blessed.